What is data analysis? Data analysis is the process of systematically applying statistical or logical techniques for inspecting, cleaning, transforming, and modeling data. This is done to extract useful information from raw data to make predictions for decision making. As a simple example of data analysis, whenever we take any decision in our daily lives, we are thinking about what happened last time or what will happen if we make that particular decision. A decision is based on analyzing what happened in the past or what we expect to happen in the future. In this data analysis tutorial, you will learn types of data analysis, data analysis process, data analysis phase, techniques of data analysis, data analysis tools, types of data analysis. Using data analysis, companies are usually looking to gain a better understanding of customers, reduction in operating costs, quicker identification of trends, and better understanding of company performance and oversight. Various types of companies require different kinds of information from raw data, which is why we have different types of data analyses. There are following types of data analysis. Statistical analysis. Statistical analysis involves collecting and interpreting data to identify trends. It is a component of data analytics. Statistical analysis can be used in situations such as gathering research interpretations, developing models, or designing surveys and studies. Statistical analysis refers to the science of collecting data and identifying trends. It's just another way of saying statistics. After collecting the data, you can analyze it. Cognitive analysis. Cognitive analytics simulate the process of human thinking to draw lessons from the data and extract hidden trends from the data. It puts all data sources such as audio, video, text, and images within the purview of analysis processes that are more widely used for decision-making and business intelligence. Some examples of cognitive analysis used today include Cortana from Microsoft, Siri from Apple, and Watson from IBM. Diagnostic analysis. Diagnostic analytics are a form of advanced analytics that examines data or content to answer the question, why did this happen? The technique uses techniques such as drill down, data discovery, and data mining. The purpose of the diagnostic analysis is to identify the root cause of an event or trend. Predictive analysis. In predictive analytics, historical data is combined with statistical models, data mining techniques, and machine learning to make predictions about future outcomes. The purpose of predictive analytics is to identify risks and opportunities based on patterns found in this data. Prescriptive analysis. In the case of prescription analysis, data is analyzed and immediate recommendations are provided on how to optimize business practices based on the predicted outcomes. As a result, businesses are able to make better and more informed decisions. Data analysis process. Data analysis can help you better understand opportunities and challenges, develop a better plan, and much more. In business, data-driven decision-making can improve results in a lot of different ways. During the data analysis process, data is examined, cleaned, transformed, and modeled. The data processing process consists of the following steps. Data requirement gathering. Gathering requirements is the first step in designing or developing a business intelligence tool. Knowledge, information, goals, and challenges are collected to gain a better understanding of what an analytical dashboard needs to be effective and impactful. Data collection. A data collection process consists of collecting and measuring relevant information. In general, data can be categorized into 4 categories based on the way they were collected: observational, experimental, simulational, and derived. How you manage research data may depend on the type of data you collect. Data cleaning. The process of data cleaning is to remove irrelevant and incorrect data from the data set, and to remove corrupted and incomplete data from the data set. Data analyzing. Analyzing the data you have collected involves using tools to transform and organize that information so that you can draw useful conclusions, make predictions, and drive informed decision-making. There are lots of powerful tools for the data analysis. Data interpretation. Interpretation of data is the process of reviewing data and reaching relevant conclusions using various analytical methods. To answer relevant questions, researchers classify, manipulate, and summarize data. It is the process of giving meaning to data that is called data interpretation. Data visualization. Data visualization is the graphical representation of information. Some examples include graphs, maps, or other design elements. Visualization is helpful because visuals can help data analysts understand and explain information more effectively. Data analysis phase. You can make seamless decisions by following 6 phases of data analysis: asking questions, preparing, processing, analyzing, sharing, and acting. Keep in mind that these are different from data life cycles, which describe the changes data undergoes throughout its lifetime. Check out how the steps can be used to solve problems on the job by walking through them. There are the 6 phases for data analysis. Ask phase. If you don't know what the problem is, you can't solve it. In order to define the problem you want to solve, consider the following. Understand the stakeholders' expectations. Concentrate on the actual problem and avoid distractions. Communicate openly with stakeholders. Take a step back and look at the whole situation from a different perspective. Here are some questions to ask yourself. How do my stakeholders describe their problems? What can I do to assist the stakeholders in resolving their issues once I have identified the issues? Prepare phase. To answer your questions, you need to decide what data you will collect and how it will be organized. The following decisions can be made using your business task. Metrics that should be measured. Search data in your database. Make sure the data is protected by security measures. Here are some questions to ask yourself. What should I do to solve this problem? How can I do research? Process phase. Clean data is the best data, so make sure you clean up your data to remove any errors, inaccuracies, or inconsistencies. It could mean one of the following. Using spreadsheet functions to find errors in data entry. Checking for extra spaces using SQL functions. Remove entries that are repeated. Making sure that the data are as bias-free as possible. Here are some questions to ask yourself. Do I need to be concerned about data errors or inaccuracies that may hinder my ability to find the most effective possible solution to my problem? Is there a way to clean my data so that it is more consistent? Analyze phase. Analyzing your data will require analytical thinking. In this stage, you may sort and format your data to make calculations easier, combine data from multiple sources, and create tables with your results. Here are some questions to ask yourself. What story is my data telling me? How is my data going to help me resolve this issue? Who needs my business product or service? What kind of people are more likely to use it? Share phase. If you are sharing your results with others, be sure to use clear and enticing visual representations of your analysis, such as graphs or dashboards. Using this opportunity, you can demonstrate to stakeholders how you have resolved their problems. As a result of sharing, your team will be able to make more informed decisions and will be able to communicate their findings more substantively. Here are some questions to ask yourself. What can I do to make my presentation engaging and easy to understand for the stakeholders? In the listener's shoes, what would help me understand this? Act phase. It's time to take action based on your data. After you have completed your data analysis, you will take what you have learned and put it into action. Your findings could be used to make data-driven recommendations to your stakeholders. Here are some questions to ask yourself. What can I do to meet the stakeholders' needs and expectations based on the feedback I received during the sharing phase? You can break down the data analysis process into smaller, manageable steps by following 6 steps. There are 4 basic steps to this process. 1. Identifying the current issue or situation. 2. Organizing the information that is available. 3. Identifying opportunities and gaps. 4. Finding the best option for you. Techniques of data analysis. Data analytics plays a crucial role in the success of any business strategy. In order to uncover insight, data analysts use a variety of methods and techniques depending on the type of data. Take this free course on data analytics to learn more about it. The purpose of this tutorial is to introduce some of the most useful data analysis techniques. Regression analysis. The method of regression analysis is used in statistical modeling to estimate the relationships between a dependent variable and one or more independent variables. This is a mathematical method for finding trends in data. As an example, you might think that how much you eat affects how much you weigh. Monte Carlo simulation. Monte Carlo simulation is a technique for analyzing how a model responds to random inputs. In most cases, this involves a three-step process: randomly generate n inputs, sometimes called scenarios. For each n input, run the simulation. This technique involves the 5 steps. To set up a probability distribution for the most significant variables. Create a cumulative probability distribution for each variable. Establish random intervals for each variable. Generating random numbers. It is a simulation of a series of tests. Factor analysis. Factor analysis is a powerful data reduction technique that allows researchers to look at concepts that are difficult to measure directly. By grouping many variables into a handful of understandable underlying factors, the results of a factor analysis are transformed into easy to understand and usable data. Cohort analysis. Cohort analysis is a type of behavioral analysis, in which you group your users based on their shared characteristics to better track and understand their actions. Cohort analysis allows you to ask more specific, targeted questions and make informed product decisions that will reduce churn and drastically increase revenue. Cluster analysis. Cluster analysis is a statistical method used to group similar items into related categories. There are 3 major kinds of cluster analysis. A distribution-based clustering method, a density-based clustering method, and a centroid-based clustering method can be used. Streaming services often use clustering analysis to identify viewers with similar behavior. Streaming services may collect the following information about individuals: minutes watched per day, total view sessions per week, etc. Time series analysis. Time series analysis is a method of studying the characteristics of a response variable, with respect to time as the independent variable. It is a specific method of analyzing a sequence of data points collected over an interval of time. In time series analysis, analysts record data points at frequent intervals over a set period of time, rather than recording data points intermittently or randomly. Sentiment analysis. When building your brand, one of the most effective things you can do is read your audience. How people feel about your product is essential to its success. And understanding the nuances of these sentiments will help you rise above your competitors. For that, you need to analyze emotions. Therefore, sentiment analysis is the use of natural language processing, text analysis, computational linguistics, and biometrics for systematically identifying, extracting, quantifying, and studying affective states and subjective experiences. Data analysis tools. There are lots of data analysis tools available in the market, but as a beginner, you can start with the Microsoft Excel and SQL and Python programming, or R programming. You can also learn Power BI and Tableau.